on the physical number of tiles, but more on the meaning of the function. So sometimes we do connect them. But the way it is presented right now, it should not be connected, because this is discrete data. Okay? Now, if you're teaching algebra, you're in an algebra class, and you want to extend it further, you want to talk about functions or something, then that's your option as a teacher. Okay, but make sure they understand that what they're dealing with right here is discrete data. I wouldn't do it on the same day. I would not talk about this very discrete data and then throw in a line and call it a function on the same day. Okay? Yes, ma'am.
Because we drew a line. So what you're saying is it's not wrong. It's just wrong for these instructions.
It's wrong for this exercise because we have concrete material. It is not wrong if you're talking only about your function.
So you would just have to be very specific in that, so that your students know this is what we're talking about versus this thing that we may have talked about, but this is this.
What she did with Dr. Brown did. First,
No, I
she asked-
understand the concept. What I'm saying is when you give that to your student.
Look, you might want things, because that's a teaching, and you can then ask them, you built these, do you think I'm gonna let you cut my materials?
Well, no, but thinking like science, whether you cut it or not doesn't mean you can't cut it. You know?
I get what you're
You know what I
saying.
mean?
I get what you're saying, but this is a very early lesson on functions, so the kids would not think about what I'm trying to say. They would, some of them were gonna draw the line, but you don't have to say what I just said, because y'all are teachers, and we want to do something with functions, and we can draw a line, we can go on, we can do this, that, and the other. You wouldn't say all of that to the students. You would leave it here and say you don't connect the dots because these are distinct, concrete items. It's like if you're trying to figure out how many kids can ride a bus, and you have, buses hold 10 kids, and you have 25 kids, you're not going to take half of that bus for those 5 extra kids. Then they'll get that, they'll understand it. Then later, when you go into your functions as pure functions, you can talk about, extrapolating and the points between and everything, that type of thing. So you would leave it here and say, I'm connecting because this is discrete data, but I wouldn't even tell them that. I would wait until the discussion came up like I just did with y'all. Okay? All right, I want to look at theirs one more time. If they extended, let's look at, let's see, Cameron, you didn't bring this through because I keep calling on her.
Yes, I am.
If you extended that, would it go through the origin?
Which one? Which one are you talking about? My group?
Your group, you have x, parentheses, x plus 2, close parentheses, plus 2. If you extended that, would it go through the origin? Just a yes or no, no discussion.
Yes.
Okay, let's leave it at that. Lisa, if you extended yours, would it go through the origin?
No.
No? Okay, all right. Next group, let's do this one over here. I think it's J. Anthony and Martin. We're gonna come back to that in a minute.
Yeah.
Don't worry, we're gonna come back to that. We'll come back to it. All right, let's look at J. Anthony. Let's give him our attention.
Okay, can you see? If we take, okay, with this problem we did, which one was it?
Number 6.
Number 6.
Second one from the top on the right. Give him our attention now, ladies.
If we take the dependent variable, and what we did was we took the dependent variable, we noticed that the dependent variable, every time we had a shape number, was increasing by 8. I'm on the right track. All right.
Okay, let's look at your drawings first.
Okay.
That was 1, and it looks like a really squared off C.
Without, yeah,
Yeah, so I see 3 line segments actually.
3
Okay,
And
so
then-
shape 2,
was 1, 2, 3, 4, 5, 6, 7, 8.
line segments.
Line segments.
So you're counting line segments as you go along.
Yes.
Did you get 8 in the second shape? Is that what you just told me?
Yes, yes, ma'am.
8
8 more, I'm sorry.
8 more,
I'm sorry,
okay, thank
8 more.
you.
The same thing happened for,
Okay, time out. Y'all don't help them. Okay? Whoever's up there, because I'm making a point about the language here, okay? So if you're helping them, then you are enabling them to use bad language. All right? All right, thank you. Go ahead, Jay Anthony.
The third shape
Yes, sir.
also increased by 8.
What increased by 8?
Number of line segments.
Good job, okay?
And the same thing for the fourth. The fourth shape also increased by the number 8. The number of line segments increased by 8.
Okay,
Is that okay?
so read your order pairs to me.
1, 3.
Okay, Shape 1 has 3 line segments.
Shape 2 has 11 line segments. Shape 3 has 19 line segments. Shape 4 has 27 line segments.
Okay, go ahead.
So after we did that, we had to come up with the formula. We found out that, you want to do that first? Okay. X equals 8 times X minus 5 is the number of line segments.
Okay, so that's your Y value.
That's your Y value.
Okay, so the way you have it written up there, your Y value is equal to 8 times your X value minus 5. That's how you have it written, correct?
Yes.
Okay, go ahead.
So when we plotted that out, okay, I messed this up. It did make a line, appears to be a line.
It was linear.
Linear, there you go, linear. For every, on the x-axis,
Yes, sir.
which we had for the shape numbers, right? For the shape number 1, the number of line segments was 3.
Okay, so from the origin.
From the
you went-
origin, okay, from the origin?
You went right 1.
Okay, there you go. From the origin, went right 1 and up 3.
And that is up because it's vertical. Okay, go
Okay.
ahead.
The same thing for, well, not the same thing. For the second shape, we went
From, tell me
right.
tell me from shape 1. where
From
you-
shape 1, we went to the right 1
Good.
and up 11.
Up to 11.
Up to 11.
Okay, so up how many more?
Up 8 more.
8 more. Okay.
8 more line segments.
Good.
8 more, yes.
From there,
From there, we went to the right 1.
from the second dot.
From the second dot, we went to the right 1
Yes.
and up 8 more.
Good. I need to apologize for calling it a dot. It's a point.
Point,
Sorry.
okay. And the same thing for the fourth, we went over, from the third dot, we went to the right 1,
Thank you.
okay, and up 8 more.
Don't let them say over, because you don't know if it's right or left. Okay. All right, go ahead.
Okay.
So your sentence?
My sentence is the number of toothpicks in each stage is equal to 8 times the stage number less than 5.
Less 5
Less 5.
or minus 5.
Okay.
Less 5 means minus 5. It's not the same as less than.
Okay.
It's less 5, because you're subtracting 5, okay? Okay, good job. So looking at your graph, you did not connect the dots, okay? Because what kind of data is this?
Linear.
It's linear. It's also what kind, because you did not connect the dots?
Discrete.
Discrete. Very good. So let me just ask you, if you extended that to the downward, would it go through the origin?
No, it'd be minus 5.
It'd be at minus 5.
Yes.
Okay. Could you explain that in your equation, why it would be minus 5?
Okay, so if we took 8 times the 1,
So the origin x would be 0.
okay, 0 times the 1, 0 times 8,
Yeah,
which is
look
going,
look at your function.
okay,
If x is 0, you
okay,
have, 0 times 8 is
0.
0, and from
Minus
0
5
is
is going to be negative 5.
negative 5. So that does not go through the origin, okay? Does not go through the origin. Good job. Okay, next group.
I guess not here.
You are your group.
You want me to do it?
Yes, ma'am, thank you. But now, think like a kid.
My principal's left me with
Yes.
no work.
He was fortunate enough to have 2 principals.
Unfortunately, it's not the
I'm being very kind. Okay, which one did you do, darling?
We did number 8, but we counted the number of darker tiles.
Okay, I gave them the option of, because it just says number of tiles, and there's two different colors. So I said, you can do only the red, only the blue, or both red and blue, right? Hoping in a classroom of 30 that some would do some of each. And if that doesn't happen, then you're gonna assign that some of each, okay? So they chose, it's supposed to be red.
Correct.
Okay.
Yes, ma'am.
Go ahead.
So we do our shape, our shapes. Please don't critique, it's not complete. But we have shape 1, 2, 3, and 4. And then we colored in the 1, so it would be exactly as on the slide.
Do you want a marker so you can kind of complete that as we talk?
Sure.
It needs to be a dark marker so we can see.
Bring one back.
Martin, give her the marker.
All right. T-table. All right, so we have X.
They did have it finished on paper, they just didn't have it on a chart.
Teresa had it finished on paper.
Yeah, Teresa had it finished on paper.
All right, we chose for our X
Okay.
notation to be the actual squares, or the shape of the
number.
square.
Uh-huh.
So it's 1, 2, 3, 4. And then we went and counted, so we had 1, 2, 3, 4 in our first shape. So we put that as our dependent. So for shape 1, the number of dark colored squares is going to be 4.
Okay.
We did the same for our second shape. We counted the number of dark tiles, and it came out to be 12.
Okay.
We repeated. And then we also predicted if we do a fifth shape, based on our patterns here, what this next number of dark tiles would be. And we noticed that between each square, we increased by 8.
What increased by 8?
From each square, the number of tiles that are the darker color that we chose increased by 8.
For each stage number or pattern number or whatever you're calling it.
Right.
The number of
Square
tiles.
but
Yeah, the number of tiles increased by 8. Okay, go
so we
ahead.
notated that. So then by this pattern, for stage 5, we determined that we would have 36 dark tiles.
Okay.
Fine.
So your can you, okay, there's your graph. Can you see it?
Oh yeah, we labeled our Y and our X axes. We made our X axis be our dependent, and we made number 1 through however many stages that we would have done.
Your x-axis is which one? Yeah, dependent or independent?
Independent.
Independent, I apologize.
Independent. And then for our dependent, was the number of darker tiles, depends on which stage you're at, is our y-axis, so we labeled that as well. And at first, we did notice that if you are not careful in counting your movements for your ordered pairs, your points, when you go to the right and up, if you are not meticulous in your numbering, you will get a point that is off. And that's what my principals ran into. They were not being careful, and they originally got a J curve.
Yeah, they did. They were very inaccurate in their counting of the
So you-
movement.
Cannot just eyeball it and just start. You must actually go for each particular. To the right 1, up 4, and from that point to the right 1, or ours is 8, not 4. I apologize. And you must make sure you follow your pattern instead of just being eyeball.
You were correct. To the right 1 and up 4. To the right 1 and up 4. Yes, you were correct. Go ahead.
Thank you. All right, so.
So your function?
I was just outside. All right, so once we decide, we redid our graph, we have what looks to be a line is increasing positively.
Did you connect your dots?
We did not connect our dots.
Did not connect the dots. Because what kind of data? Discrete, good.
Oh, all right, so we wrote it in the form of this.
Wrote what in the form?
we wrote our formula in this format.
It's really not a formula, it's a rule or a function or an equation, not a formula. We save that word formula for things like formula of area, circumference, that kind of thing.
So, because of our change of 8 in each one, we know that we had to multiply the stage number by 8 to keep the pattern going. And from there, we deciphered the rest. I deciphered the rest of them. They don't know it, I did it. I didn't tell them.
Yeah, they kind of got stuck when they were talking about that J curve.
Yes, and they were going off to the quadratic equation and we're trying to figure out how to make a quadratic equation with this data.
Yes, and so their time ran out. So she finished it. So read the sentence to us.
Okay, my sentence. The number of maroon
Giggle.
tiles equals tiles equals 8 multiplied by the stage number subtracted by 4.
Okay, so read it quickly to me.
The number of maroon tiles equals 8 multiplied the stage number subtracted by 4.
Thoughts? That one is kind of like the one over here, where it sounds like you are multiplying more than just the x.
I want to
By
add something here now.
Ma'am?
But I would like to add a word there now. That was
Okay.
on my original one.
Okay, add a word. Okay, so read it to us again.
The number of maroon tiles equals 8 multiplied by the stage number, then subtracted by 4.
Then subtract 4. It's not subtracted by 4, just subtract 4.
Not
Okay? So 8 multiplied by the stage number, then subtract 4 will work. Don't you agree? Because it's obvious that you're subtracting 4 after you have multiplied. Okay? All right. Thank you, ma'am, for being the lone person left. Okay? How about this one here? Is this one the SMART group?
Yes.
Okay, the MARC group got really frustrated with the thing, so they didn't get very far, and I will explain that.
Yes, ours is visually as appealing as all of your beautiful colored
They spent a lot of time discussing.
And this is not an anger tear. This is something too much sticky, you know?
It really is, I saw that.
We started on number 2 and, you know, we went round and round with it and it was just really difficult and so, we had to start over and then by that time, you know, we're running out of time. But that's not an excuse. Okay, so, we started off with our shapes, beginning with 1, 3, 5, 4, 7, and we translated that onto a table. Our pictures, we, you know, gathered that we have 1 circle, so we put our
They have
number.
this one, by the way, they have this one.
Yeah, number. We had that one, yes, and then we moved to number 3, and we still haven't been able to figure out number 2, you know, but.
And Jen probably stayed up all night trying
Yeah.
to work it, yeah.
So we started out with picture number 1, which had 1 ball. Picture 2 had 3 balls and so on. Picture 3 had 5, so our coordinates are 1, 1, 2, 3, 3, 5, 4, 7, 5,
They
9.
started with this one, they were completely frustrated, so that I said they could choose another, so they chose this one. The point was not to see how much they could do, the point was to get them to do one of them, okay? So I didn't care if they switched, okay?
And so then as we gathered our information, we created this graph. Mr. Estrada had to do everything on his own. We were not coloring for him, we didn't draw for him, and so he was learning. as well. And I think that because he was learning, he wanted to do something quick because we were in a hurry as well. And so the lines were not straight. We didn't have any,
Yeah, it's a sketch.
it's a
Now, when she
sketch.
said he had to do it by himself, she does not mean they did not help.
Right.
She meant they allowed him to do it by himself so that he could learn since he's not math.
Yes.
Go ahead.
And so as he was graphing the coordinates on this plot, he drew his line and he's like, whoa, there's something wrong, And so we, discussed why there could be something wrong and because, the lines aren't straight, et cetera, et cetera.
Yeah, it's a sketch.
It's a sketch. And
So your function?
our function is, I told him to write bigger. Each something figure requires 2 more units than the previous figure. So the function is 2x minus 1 equals y. So if you would plot these numbers onto the function, you would say 2 times x, x being your,
Stage number.
right? 2 times x minus your 1 should give you your y-axis
Very good.
with an
Did
answer.
not have as much time as y'all really needed.
Right.
That's very nicely done. Thank you.
You're welcome.
Okay, one question, did you connect the dots?
Yes, we did. But
We did, but
But,
We didn't know you didn't have to connect dots.
did you have to or shouldn't?
I guess, I didn't know.
Yeah,
But
shouldn't,
now I know.
and I would not expect a
Now I
fifth grade teacher to know. So shouldn't
shouldn't.
connect the dots, and why, Maura?
Because it didn't start at the 0 really. I always thought you just started at 0, but
No,
now I've
that's
learned
not,
something.
that's not why. Look at what you're graphing. You're graphing the relationship of the stage number to the number of circles,
Mhm.
okay? If you connect those dots, that means 1.5. That's got
Oh,
to fit
right,
in there.
right,
like
you were talking about
Am I
with
going to
tiles.
let you cut my circles in half?
I understand that better now
Oh, wait,
than I
and
did
one
yesterday.
of the things that was confusing my principals is they kept going back to the equation of the line and y equals mx plus d. I was like, well, yes, it could make a line, but are we including every single point in between it, or is it just this particular point to this particular object?
She said something really important. She said they kept going back to this equation that they learned, they memorized, y equals mx plus b, okay? That slope-intercept form of a line. So that's a case of having a little bit of knowledge was throwing them off, okay? Because they were not allowing themselves to think outside of that y equals mx plus b framework that they had pounded into their heads. Okay, so you've got to give your kids time, number one, and opportunities to think outside of all of this arithmetic or algebra that they may have already learned, and try to make them think of the actual physical thing that we're doing up here with the tiles and with the circles, okay? And then if you want to get to the y equals mx plus b, if you're an 8th grade teacher, you want to do that, that's fine, that will be later. But first, you deal with the physical, actual thing, okay?
And I don't know in 5th grader, but